क्या भूख लग रही है? अभी तो खिलाया था थोड़ी देर पहले, कचौड़ी नहीं खाई? फिर से लगने लगी? चलो अच्छा, मैं खाना बना देती हूँ उनके लिए। नहीं, आलू पराठे नहीं, दाल रोटी बनाऊंगी, दाल रखी है। नहीं, दाल रोटी।
Am I audible to everyone?
Yes, sir.
Hello. Okay.
Yes, sir.
So let us start with tutorial number 5. Let me share the whiteboard. One minute. Is whiteboard visible to everyone?
Yes, sir.
Okay, so let me just get the tutorial questions here, and then we can start looking at the solution. Okay, so is the tutorial question visible to everyone? Is it visible? Hello.
Yes,
Is the
sir.
tutorial question visible to everyone?
कोई नहीं आएगा इस रूम में, ठीक है? हाँ, मैं
Yes,
वीडियो
no.
ऑन नहीं है, बस आके दे देना खाना, ठीक है?
Yes, sir.
Okay, so what is been given is a first order mercury thermometer with a time constant of 30 seconds is placed in a bath at 300 Kelvin. So initially, if you look at, so there is a mercury thermometer. Let's say this is the mercury thermometer. This is the cross section of the bulb, isn't it? And outside there is a surrounding. Outside is the surrounding. So first, a first order mercury thermometer with a time constant of 30 seconds. So time constant is tau p is given as 30 seconds. It's placed in a bath at 300 Kelvin, isn't it? After a thermometer reaches a steady state, it is suddenly, so initially the temperature was T naught steady state. T naught steady state was 300 Kelvin, correct? After a thermometer reaches a steady state, it is suddenly placed in a bath of, so TO is 310. It is suddenly placed in a bath of 310 Kelvin, correct? At T equals to 0. So what we are saying is initially the temperature, outside temperature was 300 Kelvin, and this thermometer was at steady state with the outside temperature, and suddenly at time T equals to 0, this thermometer is placed into a bath with a temperature of 310 Kelvin. Okay, and we have left there for 30 seconds. So we have kept this thermometer in this new bath for 30 seconds, and again we have returned back into 300 Kelvin, isn't it? And what we have to do is we have to draw a sketch showing the temperature variation reading with time. Okay, so this is what we are interested in. So initially, let's say this is the temperature T, and this is outside temperature is T naught. Okay. we wanted to find out how this temperature T is going to vary with time, and that we have to plot. Okay, so in this case, if I look at the transfer function T dash S divided by T dash S is the output temperature, and what is the input here? Input in this case is input in this case is what is the input in this case? Input is T dot T naught dash S. This is the input, isn't it? And this should be given as first order process. So it is given as Kp tau Ps plus 1. Correct? Do you all agree with me? Yes, no?
Yes, sir.
So now this is the first order process. First order process with transfer function given as Kp divided by tau Ps plus 1. And if you remember that for a thermometer case, we have derived this, isn't it? Kp is given as 1, correct? If you remember the last class, when we have looked at the thermometer case, there we have said that the Kp is 1 and tau P is given as mCp by Ha. Correct? This is what we have proven, isn't it? Do you all agree with me or not? Do you all agree with me or not? Yes, no?
Yes, sir.
So that confidence is lacking. Only one student is answering. What about others? Do you all agree with me? Yes, no?
Yes, sir.
Yes, sir.
So see, this is the case. Let me just go back to a. See, this is what we have seen in the class, if you remember, isn't it? This is what we have seen in the class, isn't it? If you are having a thermometer like this, outside temperature is, let's say, T naught, inside temperature is T, isn't it? We can do a balance here. So we get HA T naught minus T, that is given as mCp dt by dt, isn't it? And if we find out this expression in a steady state, that becomes HA T naught S minus Ts equals to 0. If I subtract this steady state equation from this, we get the expression in a deviation form, which is nothing but HA T naught dash minus T dash equals to mCp dt dash by dt. And this mCp by Ha, we denote it as a tau p. So the equation becomes tau p dt dash by dt plus T dash equals to Kp T naught dash. Here T. Hello? Hello? कौन बोल रहे? So we are getting here tau p dt dash by dt plus T dash is given as Kp T naught dash. Here you can see that the Kp is just 1, whereas tau p is mCp by Ha. And if we rearrange this equation, what we get is T dash S divided by T naught dash S is given as Kp tau Ps plus 1. So same expression I have, the same expression I have written here, isn't it? So you can see that the same expression I have written here. See, T dash S by T naught dash S is given as Kp tau Ps plus 1. Is it clear to everyone? Hello?
Yes, sir.
Now, in this case, what is been given is, remember, initially T naught S was 300 and suddenly we have changed T naught S to 310. So what will be the value of, and then we have kept this T naught exactly as 310 for how much? 30 seconds, isn't it? So what is the magnitude of step input in this case? Magnitude of step input A in this case will be 10 Kelvin, 10 Kelvin, isn't it? So if I wanted to find out T naught dash S, that will be given by 10 divided by S. Do you all agree? Yes or no? Correct?
Sir.
So with that we will get this expression. With that we will get this equation as T naught dash S is given as. So maybe I can do it in a generalized form. So that we will get as A by S into Kp tau ps plus 1. And if we invert back into a time domain, if we invert this equation in a if we invert this expression in a time domain, what we get is T dash T is given as A Kp 1 minus e raised to the power minus T by tau p. This is what the solution of first order process when the step input of magnitude A is given. Do you all agree? This expression we have derived several times. Is it clear to everyone?
Yes, sir.
Now what is been given here? We have been given here A, we already know 10, Kp is 1, isn't it? I will write down A is 10, Kp is 1. And remember, this step input is continuing for how much time? 30 seconds. 30 seconds, isn't it? And tau p is also, we know that is 30 seconds. So we can calculate T dash T. So that will be given as 10 into 1 minus e raised to the power minus 30 by 30. Calculate this value and tell me. Calculate this value and tell me the value. Can anybody tell me the value here? Hello?
6.32.
How much?
6.32.
So that comes out to be 6.3212. So this is what we have obtained. So you can see that I can put the steady source. So T dash is what? T dash is nothing but what? T minus T steady state, which is nothing but what? Which is nothing but T minus 300. Correct. So 6.3212. Correct. So what will be actual temperature? Actual temperature will be 306.3212. Do you all agree? Do you all agree?
Yes, sir.
So this temperature I am going to get
Yes, sir.
at T equals to 30 seconds. Remember, we have to plot the response, isn't it? We have to plot the response. Okay. So now let's look at the statement given in the problem. Okay. So statement given in the problem is, initially the thermometer was at 300 Kelvin. We have suddenly put into 310 Kelvin at time t equals to 0, and we have continued with time 30 seconds. After that, again we have returned the thermometer from 310 Kelvin and put into original 300 Kelvin bath, isn't it? And we have continued there. So you can see that after 30 seconds, again we have applied the negative step. And what will be the magnitude of negative step? What will be the magnitude of negative step? Remember, this is the temperature. This is the temperature we have obtained at time t equals to 30 seconds, isn't it? From this time t equals to 30 seconds, again we have written this thermometer to a 300 Kelvin bath. So what will be the magnitude of negative step? So that I am representing by A dash. So A dash will be what? A dash will be what? Remember, the new steady state temperature is 300 minus 306.3212. So I will have a step of minus 6.3212. Isn't it? That will be the negative step. Isn't it? Correct. And what expression we are expected to get in this case? What expression we are expected to get? The expression in this case, remember, in this case, what is happening? If I look at, okay, maybe I plot the input here so that everybody is able to understand. Let me plot. So what is happening here is, let's say I am looking at T naught. T naught I am plotting. Remember, T naught is the input. So T naught at, let's say this is time. This is time T. Okay. So let's say this is 0. Then I am looking at 50 second. Then I am looking at 30 second. And then I am looking at 45 second. Then I am looking at, let's say 60 second. So now what is happening? Let's say this value here is, let's say 300. So you can see that initially this bath temperature is maintained at 300 up to time t equals to 0. Suddenly at time t equals to 0, the bath temperature increased to 310. Isn't it? Suddenly it is increased to 310. And this I have continued till 30 seconds, isn't it? And at 30 seconds, again, I have given a negative step and I came back to a temperature of 300 and I have continued. Now, with respect to this input, I am interested in, plotting the output, isn't it? So my output temperature, which I am interested to plot here is, so with respect to the same time, let's say I am plotting here T. Okay, T I am plotting. So T initially I will have T equals to 300, isn't it? But you can see that this is the 0 line, this is 15 second, this is 30 second. This is 45, this is 60. So you can see that from 300, I will continue, isn't it? And from here, the actual temperature will start increasing, isn't it? And remember what we are getting here. See, at t equals to 30 seconds, I am getting 306.3212, isn't it? 306.3212, that is what we are getting. So somewhere here, this is, let's say 306. 3212, correct. And again here there is a negative step, so it is going to decrease after this, isn't it? So negative step is starting here, and this negative step is actually translated by a time of 30 seconds, isn't it? It is translated by a time of 30 seconds. So remember, we have studied the translated function also. So in this case, when t is greater than 30 seconds, the expression we are expected to get here is T dash T will be given by A dash Kp 1 minus e raised to the power minus T minus 30 seconds by tau P. This is the expression we are expected to get. Do you all agree with me or not?
Yes, sir.
So this is the expression we have to use when T is greater than 30 seconds. So now with this expression, let us calculate the value of T at 45. Value of T. Let us calculate the value of T. We wanted to find out T dash T. Sorry. We wanted to find out T dash T at T equals to 50 seconds. So what that will be? That will be AKP 1 minus e raised to the power minus T by tau P. This is the expression which is valid. This expression is valid when T is less than 30 seconds, correct? This expression is valid when T is less than 30 seconds. So with this, we can write down this A 10 into 1 minus e raised to the power minus 15 divided by 30. So what is the value? Anybody tell me? What is the value? Can anybody tell me what is the value here? Remember, this will be T dash T. Okay, this is the expression. So T dash T will be given as at 50 seconds. Anyone? Hello, am I audible?
Yes, sir.
So what is the value? Are you all doing or not doing? Hello. So
Yes, sir.
value
Yes,
here
sir.
3.93.
3.9346. So this is the value we are expected to get. So from this, T will be given as 300 plus 3.9346. So that becomes 303.9346, and that we can identify that particular point. So 303.93. So somewhere here. So somewhere here we are getting that point, isn't it? This is the point when we are having, this is 0, this is 50 second, this is 30 second, correct? Similarly now calculate the value, T dash T at T equals to, let's say, 45 seconds. Calculate. So what we are going to get? We are going to get A dash Kp. Remember, A dash Kp, this expression is valid when T is greater than 30 seconds. 1 minus e raised to the power minus T minus 30 divided by tau P. So this expression is valid when T is greater than 30 seconds. Correct. So with this expression, calculate the value at 45 seconds. So what we are expected to get? So this will be minus 6.32, correct? 1 minus e raised to the power minus T, value of T in this case will be 45 minus 30 divided by tau P is 30. So calculate this value. Can anybody tell me what is the value? Can anybody tell me what is the value here?
Sir, minus 2.48.
Minus 2.48. Other two digit?
719.
71. Okay. So now in this case, again, we can calculate T at 45 seconds. So that will be given as, remember what is the steady state? What will be the TS here?
300.
306.3212. That will be the steady state. Why? Because this is the negative step. What will be the starting temperature? 306.32. So here steady state, that will be TS maybe I can represent that as TS1. Okay. So here at T at 45 second will be what? It will be 306.3212, isn't it? Minus minus 2.4871. Remember, this is what you are going to get. T dash T will be what? This T dash T will be TT minus TS1. So that will be TT minus 306.32, isn't it? So that will give you T at 45 second is 306. This 306 will be coming on the right hand side. So that will become 306 minus 3212 minus 2.4871. So what we are expected to get? Anyone tell me the value?
303.834.
303.834 Kelvin. So now this we can identify 303.83. 303.83, isn't it? So 303.83. So in this case, so 303.83 will be somewhere here, isn't it? Lower than this. So we will have a point somewhere here. That is at 45 second. Now similarly calculate the value at 60 second. Remember that is the question number part B. So similarly calculate T dash T at T equals to 60 second. That is part B. Okay. So what we will get again? Again, we will get minus 6.3212, 1 minus e raised to the power minus 60 minus 30 divided by 30. What is the value? Anyone tell me?
Minus 3.9957.
Minus
9957.
minus 3.9957.
57.
Okay. And we can calculate T at 60 second as 306.3212 minus 3.9957. So what is the value?
$302.3255.
300
2.325.
2.325. Okay. So 302.325. So this point again we can identify here. 302.302. Okay. So here you can see that 302, this particular point will be somewhere here. Correct. So see now what type of response we are expected to get. The response we will be having is, remember this is the first order process. So we will have a response like this. Isn't it? It is increasing and then it is decreasing. We will have a decreasing response like this. Is it clear to everyone?
Yes,
correct?
sir.
This is at 60 seconds. So in this manner, we have to plot. So this is the answer for part A and part B both. Is it clear to everyone?
Yes, sir.
So we have done part A and part B both. Now let's look at part C. So part C, in part C, what is been asked? In part C, what is been asked? I will again scroll a little bit up and we will read out the statement. So part C, what would be the reading at t equals to 6 seconds if the thermometer had only been immersed in the 310 Kelvin bath for less than 1 second before being returned to the 300 Kelvin bath. So what we are talking about here? Anyone? What we are talking about? We are actually talking about the impulse input in this case, primarily because, so see, what we are doing is at time t equals to 0, the thermometer had been immersed in 310 Kelvin bath for less than 1 second. Remember, from 300 to 310, we have put it only for moment. And the time we have mentioned here is what? For less than 1 second. We are not specifying exactly that it is for 1 second. I am saying that it is less than 1 second. If I would have specified that bath for only 1 second, in that case, it would have become pulse input, isn't it? But we are since not specifying exactly the time for which the thermometer is placed in the bath. This is the example of impulse input. Is it clear to everyone? Yes, no? Hello? Is it clear or not clear?
Yes, sir.
So see, if I would have deleted this word, if I would have deleted this word, then it would have become pulse input, isn't it? This would have become pulse input. But since this word is there, which is kind of, we are not specifying exactly the time. So what it means is, for a moment we have put, and then we have returned back to 300 Kelvin bath. So it's an impulse input we have given. Impulse input we have given. Impulse input of magnitude what? 10 degree, isn't it? Impulse input of magnitude 10 we have given. Initially it was 300, but then it became 310. So we have given the impulse of magnitude 10. So what expression we are expected to get in this case? Anyone? What expression we are expected to get? So let me scroll down. In part C, actually the expression will be for the expression of impulse input. For impulse input, if the impulse input of magnitude A equals to 10 is given, A is equals to 10, then what we are expected to get? What is the response for the impulse input? T dash T will be given as AKP by tau P e raised to the power minus T by tau P. This is the expression we are getting. And you can see that this particular expression, you can derive also. You can derive directly from the step input. So you can see that this is the expression for step input. Where is the step input? This is the expression for step input. You can differentiate this particular step input with respect to T, and you are going to get the response for impulse input directly. Okay. So in this case, this is the expression, and you can also derive from the first principle also. So see, for instance, what you are going to get, you will be getting T dash S by T naught dash S, that will be given as Kp tau Ps plus 1. Let's say T naught dash S is A by only, it's a impulse input, isn't it? So T naught dash S will be just A, isn't it? Correct. So in that case, T dash S will be AKP divided by tau Ps plus 1. And if you invert this into a time domain, this is the expression you are expected to get. T dash T comes out to be AKP divided by tau P raised to the power minus T by tau P. Is it clear? This is very easy also here. You can see that this numerator you divide by tau P, so you get AKP by tau P. Denominator will be S plus 1 by tau P. So what will be the inverse of this? AKP by tau P raised to the power minus T by tau P. Is it clear to everyone? Is it clear?
Yes, sir.
Yes. Okay. So now with this expression, what is being asked, if this impulse input is given at time t equals to 0, then what will be the value of thermometer after t equals to 6 seconds, isn't it? T equals to 6 seconds, what is the value? So in this particular equation, we can calculate that. T dash T is given as A is 10, Kp is 1, tau P is 30, e raised to the power minus 6 by 30. Calculate the value. Calculate the value.
Sir, 0.2729.
0.2729 is what you are expected to get. So T dash T is going to be 300 plus 0.2729. So this will be 300.2729 Kelvin. This is the value you are expected to get. Now let's say if you are having, let's say, pulse input. Remember in this case, we said that since the time was not specified, that is why impulse we have taken. But let's say if you would have specified that the time is exactly 1 second, then it would have been the pulse, isn't it? Pulse input. So for pulse input, again calculate and see what you get. Calculate for a pulse input, see what you get. For a pulse input, anyone? So what will be the expression for the pulse input? Anyone? For a pulse input, anyone, what will be the expression? Can you calculate in a similar way, the way we have done so far? So you have to first calculate what will be the value at 1 second, isn't it? So what will be the value at 1 second? You calculate that, correct? What will be the value at T dash? So expression in this case, what expression you are expected to get? You are expected to get, I'll just do that for you. Just wait. So T dash T at T equals to 1 second. So what you are going to get? 10 into 1, 1 minus e raised to the power 1 by 30, isn't it? Calculate this value. Can you tell me what is the value? Can anybody tell me this value?
Sir, 0.3278.
0.3278. Okay. Now this 0.3278 will be the magnitude of the step input, isn't it? Because remember in the pulse input, you are looking at t equals to 6 second, which is after 1 second. So you have to use the translated function in this case. So what you are expected to get, the expression you will be using in this case will be, the expression you will be using in this case will be T dash T at t equals to 6 second will be given as A dash Kp 1 minus e raised to the power T minus 1 by 30, isn't it? This is what the expression you are expected to get. Now what will be A dash? A dash will be minus 0.3278. Kp is 1 minus e raised to the power minus T is 6 minus 1 by 30. Calculate this value and give me. Calculate this value. Is it clear what I'm doing? I am using the same methodology which we have seen in part AB here. But now we are specifying that the pulse will be occurring for 1 second, isn't it? Correct? What value we are expected to get?
0.05032.
0. Please repeat.
0.05
0.5032.
032.
There is no minus sign here.
Yes, sir, minus 1.
So minus sign is there, isn't it? Now this is what? This is nothing but TT minus TS1, isn't it? And what will be TS1? TS1 will be 300 plus this, isn't it? 300 plus this, isn't it? So in this case, TT will be what? 300.3278 minus 0.05032. Correct. So calculate, give me this value. Give me this value.
300.277.
300.277. And now you can see if I subtract 300 from here, you can see what value we have obtained earlier. You can see what value we have obtained earlier. 300.2729. And here we are getting 300.2770. It is slightly different. Why? Because the time of the pulse we have taken 1 second, isn't it? So slight change is there in the value. Otherwise, more or less the value is same. Do you all agree? Yes or no?
Yes,
Make
sir.
sense? So this is the additional part we have done. This is the additional part we have done. It has not been asked in the question. This part, this additional part we have done. Why? Because we wanted to understand, let's say if we use the pulse input, this is the additional part we have done from here to here. Just to understand if the pulse is given, then what value we are expected to get. Isn't it? Let's say if we give a pulse, then what we are expected to get is the additional thing we have calculated here. Is it clear to everyone? Hello?
Yes, sir.
Okay. So I think that is all in this tutorial. We will stop here and we will continue. I am downloading your attendance. Let me just download the attendance. So I have downloaded the attendance and I'm closing the meeting. Okay. So see you tomorrow.